Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. My name is Muhammad Aiman bin Muhammad Zulkernaini. My matric number is B0819101179. So I'm from BEE program, which is section 1/1. So this is my first lab for digital electronic, which is lab 1 logic gates. So let's start with the lab. So I will show you how the function this lab for each gate. So for the part 1, it need we to show the function for each gate, which is AND gate, OR gate, NOT gate, NAND gate, NOR gate, and XOR/NOR gate. So let's go the Proteus. So actually I have done the lab and I get the result. So this is my video for result. So for the AND gate, so we just take AND gate. AND gate. So we put here and we connect to the LED for this and this to the A switch. D for this for this switch. So firstly, it need we to show the result for 0, 0. So we play first, and this is for the 0, 0, which is 0, A0, B0. The output is 0. LED not bright, not show the result. So for the second, it need A0, B1. So A0, B1. LED start still not brightness, show the brightness. So for the third A1, B0. A1, B0. So LED still not function. So for the last one, A1, B1. So we see the result. The LED function. So the output is 1. So this is for the AND gate. And the second is OR gate. So we put the OR gate, connect it, the connection. So this to A and this to B. So that is the function. So okay. So for the A0, B0, the output is LED not function. So for the A0, B1, the LED and function so the output is 1. So for the third A1, B0, okay, B0, A1, LED function, so the output is 1. So for the last A1, B1, so LED still function. So this is the result for all gate. So for the next is NOT gate. So stop this. We show for the NOT gate. Delete this. So actually just for the NOT gate can use for one button. So I choose to show you for 2 buttons. I will follow this instruction. So for the NOT gate, play first, then NOT gate. So sorry, A0, B0. So the LED function. So we put 1, and then A0, B1. LED not function. So we put 0. The B0, A1. also the function, and then A1 B1. So the result is this, not function for the A1 B1. So we go to the next gate, which is NAND gate. So stop, delete this wire, then pick NAND gate. So for the NAND gate, this go to A, this go to B. So play. Okay. So for the NAND gate, A0, B0, LED function, so the output is 1. So for the A0, B1, LED still function, so we put 1 for the output, and then A1, B0, the LED still functions, so we put 1 for the this, and the last A1, B1. So the output is LED not function. So this is the result for the NAND gate. Okay, so for the next is NOR gate. Okay, stop, change to the NOR gate. Okay, for the NOR gate, A, go to B. Okay, for the NOR gate, we play first, run the Proteus. So for the NOR gate is 0B0. So A0, B0. The LED is function, so the output is 1. So A0, B1, A0, B1, LED not function, so we put 0, and A1, B0, LED still not function, so we put 0, and the last one, A1, B1. A1, B1, so LED still not function. So this is the function for the NOR gate. Okay, next we go to XOR gate. So we stop first, XOR gate, we put, delete first, we put XOR gate, then put this, okay, let's play. So how the function for XOR gate? So for the XOR gate, A0, B0, so A0, B0, the LED not function, so the output is 0. So for the A0, B1, the LED function, so we put the output is 1, so 1, 0. So the output is still so function, so the output is 1, and then A1, B1, B1, sorry, okay, A1, B1, so the output, the LED not function, so the output is 0 lah. Okay, we go to the next is XNOR gate. Actually, my Proteus do not have the XNOR gate, so I replace it for the 4077. So I have searched to Google, it same the function for the XNOR gate, so I replace it with 4077. So for the XNOR gate work, then we connect this, this. So for the XNOR gate, for the first function A0 B0, okay, A0 B0, the LED is function, so A0 B1, the LED not function, so the output is 0, and then A1 B0, the LED not function, so we put the output is 0, and then A1 B1, the LED function, so the output is 1 lah. So for the next is part 2, which is this, the instruction need we to do the PCB layout. So I have done the PCB layout, so I show you for the AND gate only. So this is my PCB layout for the AND gate I have done. So this is our lecturer give us to choose which is we want to do or not for the PCB layout. So I choose to do the for the AND gate only. So this is my the PCB layout. So uh, we can see the 3D. Where is 3D? 3D. Okay, so this is the 3D visualizer for the my AND gate. So as you can see, oh sorry, okay, oh, okay. So this is my VCC power supply. So this is my power supply for the IC. This is my LED resistor, and this is push button. So we go to the part 3. So for the part 3, it need we to the follow the circuit and see the function. So for those part 3, this is the circuit. So I will draw it. It first need uh, uh, NOT gate. So two NOT gate, two NOT gate, and then AND gate, two AND gate, two AND gate. And for the last one, OR gate. Oh, sorry, OR gate. Okay. So for OR gate A, okay, so these two this, and then this, 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 this. So for this, go to B. So B is here. So this go to the A. A is here. So next, this go to A. A must go to the B. So let's see. Then the result is for the part 3 set. Okay, so for the part 3, the result is That is, so see it. So A0, B0, A0, B0, the output is 0. So for the A0, B1, the output is 1. For the A1, B0, the output is 1. And then, so the A1, B1, A1, B1, the did not function, so the output is 0. This is for the part 3. And then for the part 4, construct a logic circuit extreme integer. You produce software and record the output in the truth table. So same, I will do the circuit first. So delete, oh, sorry. use not use. So this wire delete first. Okay, this is one. Okay, this is NOR gate. Okay, gate go to here. Okay, then this go to A. This go to A, and to both of this go to B. Okay, so this is the circuit for the part 4 as no equivalent circuit. So let's see the function. So for the part 4 function, so go to my result. So this is part 4, the part 4 result. So first A0, B0, A0, B0. So the LED is function, so the output is 1. So next A0, B1, the did not function, so the output is 0. And then B0, A1, the LED also not function, the output is 0. And then lastly, for this lab, A1, B1 for the X no equivalent circuit. So for the last A1, B1, the LED is function, so the output is 1. So that's all from me for this lab 1 digital electronic. So I wish thank you for the Dr. Lim for the video instruction, and bye.